All right, so I have the perimeter of MAT is 12 units. So that's this triangle here. I know that this side is congruent to this side, so I'm going to set those two equal to each other. Whoops. Adding this x squared over, I would get a 2x squared plus a 7x squared. Since this is a quadratic, I need to set this equal to 0. So I'm going to subtract this 4 over as well. Okay. So I have a quadratic equation that I'm going to need to use the x method on. At the top of your x is your a times your c, so a 2x squared times a negative 4 is a negative 8x squared. And the bottom of your x is your b. That's a positive 7x. So I need two numbers when multiplied together equal negative 8x squared, but when added together equals 7x. That's going to be an 8x and a negative 1x. All right, so now rewriting the quadratic without the plus 7x in, I have a 2x squared plus an 8x minus an x minus a 4 is equal to 0. Grouping my first two terms together and my second two terms. The greatest common factor out of my first two terms is a 2x. And I'm left with an x plus a 4. I would need to take out a minus 1 to be left with an x plus 4 out of my next two terms. So my two binomials are a 2x minus a 1 and an x plus 4. So if I set both of these equal to 0, I would wind up with x is equal to a 1/2 or a negative 4. Now if I put a negative 4 in for any one of these, like let's say up here, a negative 4 squared is a 16, but then plus a 7 times a negative 4, which is a negative 28. So I would wind up with a negative side length, so x cannot be negative 4. If I put 1/2 in, though, it does work out. So x is 1/2. That's not what they want you to find. They want you to find, knowing that the perimeter of MAT is 12, they want you to find MA. So we need to put this 1/2 in here. So when I do that, sorry, this is MT, I apologize. I have a negative and then a 1/2 squared plus a 4. So this comes out to be a negative 1/4 plus a 4. So this is going to be a 3.75. Or a 3 3/4 if you want to write it as a decimal. Well, if MT is 3.75, that means AT is 3.75 because this is an isosceles triangle. And so if I do 12 minus 3.75 minus another 3.75, I wind up with MA, which is what I was trying to find, being 4.5. This is my answer. Okay, looking at number 38. So I see x's and y's. Most likely we're going to need to set up a system of equations. The first system I'm going to set up is that my exterior angle equals the sum of my remote two interior angles. That's using the exterior angles theorem. I'm now going to simplify Okay. From here, I'm going to put this in standard form. So what that means is I'm going to get this x over here. So I'm going to subtract x over here. So I wind up with an x. I'm going to get this 3y over here. So I'm going to subtract 3y. So I wind up with a minus y. And I'm going to get my constant to the other side. And that's a -2. So I'm going to keep this in my back pocket because I'm going to use that in a little bit. But I need to set up another equation. So there's a couple of other equations that you can set up. I'm going to set up the triangle sum theorem. So that's this plus this equals this. If you did a different one, that's completely okay. Sorry, I think I said that wrong. They all equal 180 together. All right, simplifying from here, I have an x plus another x, so that's a 2x. I have a 2y plus a y, that's a 3y, plus another 3y, that's a 6y. And then I have a 56 plus a 32 plus an 80, which is a 168. And putting this into standard form, I'm going to want to get this 168 over to the other side. So I subtract that over, and I wind up with this. All right. So now we're going to use the two start equations to solve this system. I'm going to line my equations up. So my first equation was an x minus a y is equal to a -2. And my second equation is a 2x plus 6y is equal to 12. Now, if I added these together, I would not eliminate a variable. So I need to multiply one of these equations by something to be able to eliminate a variable. I'm going to try to eliminate y. So I'm going to multiply the top equation by 6. This is what I get. And I'm just going to rewrite my bottom equation. Adding the two equations together, I get this. So then dividing by 8 on both sides, x comes out to be 0. So now I'm going to take this 0, I'm going to put it in for one of these original equations. It does not matter which one. I'm going to do the top one. A 0 minus a y is a -y. And then I'm going to divide by -1 on both sides to get y is 2. So x was 0, y was 2. That's what I was asked to find. So that is my answer.